The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
This is number 14. Sinusoidal water waves are generated in a large ripple tank. The waves traveled at 20 centimeters per second, and their adjacent crests are 5 centimeters apart. The time required for each new whole cycle to be generated is what? So I drew this out for a picture, which you should always do. Here's the water tank, and here are the waves. They're going in a velocity this way. Okay? Just for me, I like to go left to right. So they're being generated by some pump over here, and it's making waves go this way. And their adjacent crests are 5 centimeters apart. The velocity is 20 centimeters per second. We need to know how to make this information that we're given useful. We need to know what do you notice about here first? This is in centimeters per second. So that means velocity should be really 0.2 meters per second. Always put it in meters per second, because that's how all the equations are meant to be, is with meters per second. Same thing for here. This is also in centimeters. Now, what is this piece of information? We have adjacent crests. As you see, I drew this dotted line here to show how the waves are really, it says sinusoidal in here. The waves are really going up and down, up and down, up and down like a sine wave. So that means adjacent crests is the wavelength. So the wavelength is 5 centimeters or 0.05 meters. Okay, so now we know this, and we know velocity and wavelength, and we are looking for time period. If I'm correct. Yes, we're looking for frequency. We are looking for frequency. The time required for each new whole cycle to be generated is... No, we're looking for time period. We're looking for time period. Sorry, hard to read my notes. Okay, so how do we find this time period? Time period relates to 1 over frequency. Right? That's pretty much how we do it. How can we get frequency? We're not given it, but we do know that wavelength times frequency is equal to velocity. We know this, and we know this. So that means we can find frequency. So let's go ahead and find that. Frequency is then equal to V over wavelength, which is equal to 0.2 meters per second over 0.05 meters, which equals to 4. 1 over seconds, or seconds to the negative 1. Seconds to the negative 1. That's the common way to put it. So now we know that frequency is equal to 4 seconds to the negative 1. Now we can go ahead and put that into t. T is equal to 1 over 4 seconds to the negative 1, which is equal to then 0.25 seconds. That is your answer. You have to find out what t is, or find out what you're looking for, find out what you end up looking for, because you're not given enough information for this. Find out for it, and then plug it back in. Classic physics.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.